Now let's have a look into one example. So we will do the two-tailed test hypothesis testing. So the problem statement goes this way. The mean lifetime, let's call it as E of X of the light bulbs produced by Lighting Systems Corporation is 1570 hours with a standard deviation of 120 hours. The president of the company claims that a new production process has led to an increase in the mean lifetimes of the light bulbs. If Joy if Joy tested 100 light bulbs made from the new production process and found that their mean lifetime is 1600 hours, test the hypothesis that E of X is not equal to 1570 hours using a level of significance 0.05 and 0.01, 5% and 1%. Okay, so that's what is a problem statement. So let's formulate a hypothesis. Let's formulate null hypothesis first. The null hypothesis is H naught mu sub x is equals to 1570 hours. 1570 hours. And let's formulate alternate hypothesis. Alternate hypothesis H1 or H sub naught is mu sub x is not equal to 1570 hours, and this is our alternate hypothesis. So this is not equal to 1570 hours. That's the reason we call this as a two-tailed test. Okay, next let's calculate, since mu sub x not equal to 1570 includes numbers that are both greater than and less than 1570. This is a two-tailed test. From the available data, the normalized value of the sample mean is this. Okay, so from the available data, we have calculated the normalized value of the sample mean. So let's take x value. So after Joy tested, you see here, Joy tested 100 light bulbs made from the new production process and found that their present observation is 1600 hours. So that's what the sample mean, sample mean. So our sample mean is 1600 and the hypothesized population mean is 1570. So 1600 minus 1570 divided by, so obviously sigma standard deviation, that is around 120 hours, and the total sample size, which is square root of n, sample size is square root of n. Okay, so what we got is 2.50. So as it is a statistical test, obviously we have to use x sample mean minus hypothesized population mean divided by standard deviation of respective data divided by square root of sample size. That's what, and we got the 2.50. Now, the first question is if a level of significance is 0.05, so what is going to happen? So let's begin with that. At a level of significance 0.05, so at 0.05, critical value critical z-score value is between, as it is a two-tailed test, left side left of minus 1.96 and right side right of acceptance region, which is right of plus 1.96. These are the two zones. Let's plot it. Yeah, if you see this, so this is the standard normal curve or standard normal curve or z distribution, and here you see on left side and on right side. So left side left of the minus 1.96, on right side right of 1.96. These are the critical values, minus 1.96 and plus 1.96, and these areas are called critical regions or rejection regions. Rejection region or critical region, and you can see that it's 2.5 and this is 2.5 percentage. Total it's 5.5 it's total 5.0 percentage na. So out of that 2.5 percentage on left side and 2.5 percentage on right side. So that's because it's a two-tailed test. So my critical values are minus 1.96 and plus 1.96. So what is my z-score? My z-score or z-statistic with respect to the experimental data calculation is 2.50. Okay, these are my Jones rejection regions, and my z statistic value is 2.50. So z is equals to 2.50. If you see here, which lies outside the range of two rejection zones. So you can see here our z statistic lies here. Okay, z statistic lies here, which is outside of the acceptance region. Which is outside of the acceptance region. You see that this is the acceptance region, and which lies outside of the acceptance region, and it's actually in the right side of the 1.96, which is a rejection region. There we can see. So this is the z statistic, which is 2.50, which fell inside the rejection zone. So for a two-tailed test, for that's it, since z is equal to 2.50, which lies outside the range of minus 1.96 comma 1.96, that is, it is in a rejection region, so we reject null hypothesis at the 0.05 level of significance, and we accept alternate hypothesis, which means that the difference in mean lifetimes is statistically significant. So let's try to put it in a code so that let's write a piece of code, and let's use Python to solve this. Okay, so two-tailed test. In that, the first one is 5 percentage level of significance, LOL. Okay, let me put it. Level of significance. Okay, so let's import. The first step is to import the necessary libraries. Let's import scipy.stats as stats. Then it's the most important step. The next step is to define the null and alternative hypothesis. So null hypothesis mean is equal to 1570 hours. Let me say here underscore hr. This is 1570 hours, and alternate hypothesis mean in hour is not equal to 150. Let me put it 1570. So that's what is our alternate null hypothesis. Okay, so this alternate hypothesis is done. Now next step is to calculate the sample mean and the sample size, everything. So data details about the problem. As we have discussed, sample mean, it is 1600, and sample underscore size, it's known 100 bulbs he has taken. Okay, now let's calculate the, and the sample standard deviation was also given. So sample standard deviation, which is 120. So now it's time to calculate z-score. Okay, to calculate the z-score, obviously we have to use the same formula. Z-score is equal to sample mean minus null hypothesis mean. Okay, so which should be divided by standard deviation. Okay, where is that? Our standard deviation, just a minute. Yep, standard deviation was okay, so let me call up the standard deviation, sample std, and which is divided by, let me call up this to import numpy as np, and np dot square root of sample size. Okay, yep, there is some issue. Okay, alternative hypothesis, this is not equal to. So let me put it here. Anyway, this is not yeah, so let's print z-score, and here it is, z-score at 2.50. so now it's time to calculate the p-value. It's time to calculate the p-value. Let's take the p-value. Just a minute. Yep, calculate p-value. So p underscore value is equal to 2 times. Obviously it's a two-tailed test, so that's the reason we'll be multiplying, because we want on both sides. And 1 minus stats dot norm dot cdf which is cumulative density function, that's what, and then absolute of z-score. Let me check the z-score here. Yeah, and that's it. And let me print the p-value here, and we got around 0.0124. That's what the probability value we got. Okay, anyhow, next. So now as per our question, we have taken a level of significance of 0.05. Now we have to cross check what's the condition there. Okay, so now define the significance level, define the significance level, which is significance level 1 is equal to 0.05. So now let's cross check, let's finalize, let's take a decision. Let's take decision based on the p-value. So here, if p-value is less than significance level 1, then print reject the null hypothesis at the 0.05 level of significance, else print fail to reject the null hypothesis at the 0.01 level of significance, and let's execute. So reject the null hypothesis, okay, at the 0.05 level of significance, because you got a probability value of 0.01, which is fundamentally and basically lesser than 0.05. Okay, so that's the reason it has fell anyway. Here we can see here it has fell inside the rejection region, and we have taken a decision. We reject null hypothesis at the 0.0 level of significance, and we accept. We don't need to say we accept. Once you reject the null hypothesis means other way you will be accepting the alternate hypothesis. Okay, which means that the difference in mean lifetimes is statistically significant. Okay, so now let's also look into the second case, which is a level of significance of 0. That's what is the second case which is available for us. So we will look into that also. At the 0.01 level of significance, so then the critical values would be minus 2.58 on left side and 2.58 on right side. The acceptance and rejection regions that you can see on the screen in figure now. Okay, so this is what the condition. So these are the red marked regions are rejection regions. Okay, and so as the level of significance is reduced to 1%, so the critical value has been increased by 2.58 on right side and minus 2.58 on left side. Okay, that's because your level of significance has decreased, and your confidence interval has gone to 99%. Okay, so that's what is this. And now let's take since our z-score remains same, it's 2.50, which lies actually, yeah, because it's 2.58 is the critical value and 2.50 is here. Since 2.50 lies within the range of minus 2.58 to 2.58, which is actually an acceptance region. So what we do, which is the acceptance region, minus 2.58 to 2.58, we accept, we fail to reject. In spite of saying we accept, it's the best way to tell is we fail to reject null hypothesis at the level of, at the 0.01 level of significance, which means that the difference in mean lifetime is not statistically significant. Let's write the piece of code for this too. So this time what I'm gonna do is I'll just take this and I'll paste it here for the remaining. So level of significance 2, and it is this time it's 1%, is it's 0.01. So if p value is less than 0.01, which is level of significance now, then we have to reject the null hypothesis. If it is greater than that, then we fail to reject the null hypothesis at the 0.01 level of significance. Obviously, uh, you can see here your p-value is 0.0124 and your level of significance is 0.01. So p-value is greater than 0.01, our significance level 2, which means we are fail we fail we failed to reject the null hypothesis at the 0.01 level of significance. Okay, that's how a two-tailed test works with different levels of significance.